Today on the podcast, we're talking about something really interesting Microsoft is doing with AI. And of course, this has to do with science, which, as you know, medical science and mixed with AI is one of my favorite topics. What's happening here is that Microsoft is actually open sourcing something called EvoDiff. So this is a novel protein generating AI. And this has a lot of implications for science, medicine, healthcare, a lot of different areas. So today on the podcast, we're going to be diving into this. We're going to be talking about what some of the implications are, why I think this is exciting, and potentially a groundbreaking move. So without further ado, let's dive into it. Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Make sure that you go to aibox.ai, link in the show notes, to join the waitlist for our new AI platform. We're going to be launching an incredible platform that allows you to build anything you want with workflows in AI. So you're able to chain together ChatGPT and image generators and audio generators to make really powerful apps for your organization, or you can host them on our marketplace and actually generate royalties from them. So make sure to go to aibox.ai and join the waitlist. In addition, if you like the podcast, if you could do me a massive favor and please leave us a review on Apple or Spotify or wherever you listen to your podcast. This helps me be able to get better guests on here as they check the reviews to see how you guys are liking it. So if you could please do that, I would really, really appreciate it. Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app or go to spotify.com/podcasters to get started on your podcast today. The landscape of protein design, which is a cornerstone in understanding and treating diseases, I think is on the brink of a transformation. So proteins, for those that don't know, essentially serve as the natural molecules executing critical cellular functions. But creating them in a lab has often been it's really costly and it's very complex. However, this is all potentially about to change. Microsoft claims to have simplified this really intricate process with its newly introduced framework, which is called EvoDiff. So traditionally, protein design has kind of a bunch of extensive computational and human resources that are needed in order to do it. And scientists have to conceptualize a protein structure capable of performing specific bodily tasks. And then once they do that, they have to determine the sequence of amino acids that would likely fold into that structure. Okay, so kind of complex scientific stuff, but protein folding is essentially as proteins have to adopt, they have to essentially adopt these precise three-dimensional shapes to function as they're intended. So that's what protein folding is. So EvoDiff offers a radical kind of departure from what has been the norm for so long. So according to Microsoft, the general purpose framework can churn out, high fidelity, diverse proteins based solely on a protein sequence. So this completely sidesteps the often very cumbersome task of requiring structural information about the target protein. And this open source framework holds promise in essentially applications ranging from generating enzymes for novel therapeutics to also kind of like facilitating new industrial chemical reactions. So Kevin Yang, who is a senior researcher at Microsoft, he envisions EvoDiff as a groundbreaking tool in protein engineering. That's what he said. He said, quote, "We envision that EvoDiff will expand capabilities in protein engineering beyond the structure function paradigm towards programmable sequence-first design." So he also said, with EvoDiff, we're demonstrating that we may not actually need structure, but rather that protein sequencing is all that you need to controllably design new proteins. Really, really interesting stuff. So I think at the core of EvoDiff is around a 640 million parameter model trained on a comprehensive data set spanning various species and functional classes of proteins. So for the, uninitiated, parameters in an AI model are essentially learned from training data and essentially dictate the model's competence. So data sources for the model include the OpenFold dataset for sequence alignment and UniRef50, which is essentially a subset of data from the renowned UniProt consortium database. So drawing parallels to cutting-edge image-generating models like Stable Diffusion and DALL-E 2, EvoDiff operates as a diffusion model. This is really interesting because, these diffusion models, for those that don't know, essentially what that really means is it's like so we'll go to like images, but it's really interesting they've moved this over to protein and science and other areas. So this is kind of like in my opinion, this is another testament to like how cool and impactful a lot of these advances in AI are, because they're not just like for generating images on Midjourney or generating text on ChatGPT. Like the way that they're built and the architecture of these tools is now being used in so many other things. And actually, I'll also just as a side note say I think it is really incredible. People just hear the word AI, and in their brain they're like, yeah, AI is just like a computer doing stuff. And I think they don't really realize the fundamentally like how incredible it is that we have image AI and also text generating AI coming up at the same time, because these are actually fundamentally different in how these things function. Like, of course, you need data in for both of them, but for diffusion models, which is what this new EvoDiff is using, but how it works for images, essentially a diffusion model means that like when an image is rendering, it's kind of like ChatGPT where it's predicting the next token, but instead of predicting the next token, it's predicting the next pixel in an image. And so you can imagine it where it's like a square, and you've probably seen this if you've used something like Midjourney, where you like look at the image and it's like blurry and it slowly kind of like comes into focus, right? So that's what a diffusion model is doing. It's essentially rendering it where it like renders a really fuzzy bunch of pixels in a square, and then it's like if we were trying to do X, Y, and Z, like how would the pixels change? What's the prediction? And it slowly like almost like comes into focus. It's diffusion, and it's coming into focus of what it's actually supposed to do, predicting all the pixels and the placements. Super, super interesting stuff. So it's really cool because that same technology is now getting moved into other areas like EvoDiff. So essentially how EvoDiff works is that it refines a protein made mostly of, quote unquote noise, and then gradually filtering out the distractions to arrive at an accurate protein sequence, such as, the same thing that diffusion models are, kind of how they're not like confined to obviously proteins. Their applications really stretch across a bunch of different domains, including music and speech synthesis. So really that diffusion model, I think, is very, very like influential in the sense that, like, of course, we discovered it to create images, but now we're literally using it for image generation. We're using it for protein generation. We're using it for like music creation, speech creation, all sorts of really interesting things. And it's kind of like this diffusion model that's doing all of that, and really, really cool stuff. In any case, EvoDiff can not only create new proteins, but it can fill in the gaps in existing protein design. So that's according to Ava Amini, which is another researcher, a senior researcher at Microsoft. So the framework's versatility allows it to essentially generate protein amino acid sequences meeting specific functional criteria, and even to synthesize quote unquote disordered proteins. So those don't typically fold into a final structure, but they still play vital roles in biology and diseases and stuff. So very, very interesting. And while EvoDiff appears promising, I think it's fairly essential to note that the research has yet to kind of undergo peer review. So this is coming out of Microsoft. And then Sarah Alamadari, who is a data scientist at Microsoft, cautioned that there's still, quote, a lot more scaling work needed before commercial application, and also said, quote, "This is just a 640 million parameter model, and we may see improved generation quality if we scale up to billions of parameters." So I think looking ahead, the EvoDiff team plans to kind of validate the generated proteins in the lab. If successful, this is going to pave the way for the framework's next iteration, which is opening new vistas in protein engineering and healthcare innovation, all sorts of really exciting things. So definitely a story we're going to continue following, and we're really excited to see how this continues to advance and play out.
This episode is brought to you by Shopify. Forget the frustration of picking commerce platforms when you switch your business to Shopify, the global commerce platform that supercharges your selling wherever you sell. With Shopify, you'll harness the same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Sign up today for your $1 per month trial period at shopify.com/tech, all lowercase. That's shopify.com/tech.
TIAA is on a mission. Why? Because 54% of Black Americans don't have enough savings to retire. So in collaboration with big-name artists like Wyclef Jean, TIAA released Paper Right, new music inspiring a new financial future. With 100% of streaming sales going to a nonprofit that teaches students how to invest. Stream Paper Right now and help close the gap.
Thank you for listening to the AI Chat Podcast. If you enjoyed the podcast, I'd appreciate it if you rate me wherever you listen to podcasts. And if you're looking for an innovative group of AI enthusiasts, make sure you check out our Discord channel and also our Facebook community. It's obviously a lot more interactive than a podcast where we can actually share software tools, prompts that we're using in everyday AI. I'll leave a link for those in the description below.